Ready, sir. Is my screen is shared, sir?
Start the class, sir.
Okay. Welcome to webinar classes to learn physics. This is M.V.P.Prasad, JN Physics, Tsrjc, Hasanparthy. At first, I am very thankful to our Secretary, sir, to give this opportunity. Students, till now, you learnt about the motion in a straight line and motion in a plane. Now, we are going to learn the new lesson, that is laws of motion. While considering the motion of the body, what are the laws associated with it? Students, from now onwards, you have to pay more attention on these classes. Why? Because these lessons are very important, not only for IPE, but also JEE examination. Okay, let us start our lesson. That is Unit 5, Laws of Motion. At first, we'll introduce the class with Aristotle fallacy. So Aristotle phrased that an external force is required to make the body in the motion. That means, suppose a body is on the table. If you apply force on it, it will move. Similarly, if I kick a football on the court, it travels some distance and it will stop. That's we know. That means Aristotle phrased that an external force is required to make the body in the motion. So that after some time it will stop, means he phrased that a continuous external force is required to make the body into the motion. But it is the flaw. There is a flaw in his argument. So we will discuss later in the same chapter. Afterwards, Galileo. I think you heard about the Galileo's name. He is the scientist who discovered telescope. So Galileo phrased that he considered actually an ideal case, that is some frictional surfaces. He conducted some experiments. See this diagrams. There are two inclined planes are arranged like this. Suppose if you release a ball at one of the ends of the plane, it will move. Just imagine these inclined plane surfaces are frictional surfaces. Okay, now if you release the ball travels like this, and of course it travels like in this other plane, the same height from the ground. Suppose if you increase the slope like this in the second diagram, and if you release the ball, and of course it also travels the same height like this to the another plane. In the third diagram, the second plane drags the horizontal surface. Now, if you release the ball at this position, and then it travels to infinite distances. Means what? If the frictional surface is present, the body is continues to move into the motion because there is no obstruction. So he concludes that an object moving on frictional horizontal plane must neither have acceleration nor retardation. Suppose if a body is moving in a frictional surface, it doesn't have acceleration or retardation because there is no opposite force acting on it. Strictly, it is at the frictional surface. So it is the loss of we introduce the loss of inertia. So inertia means if the body is in the state of rest, it is in the rest only. If the body is in the motion, it is in the motion only. That means the body cannot change itself, its state of its position. So that is nothing but loss of inertia. In this way, Galileo introduced the law of inertia. Newton built on Galileo ideas and laid the foundation of mechanics in forms of three laws of motion that go by his name. Actually, Newton took the ideas of the Galileo and he framed three laws by his name. Those are called Newton's laws of motion. Newton's laws of motion. So Newton proposed three laws. First law, second law, and third law. Now we will discuss about Newton's first law of motion. Every body continues to be in a state of rest or of uniform motion in a straight line unless it is compelled by some external force to change its state. Students have understand this very important law. If a body is in the state of rest, it is in the rest motion only. If a body is in the motion along the straight line, it is in the motion only. Unless we exert force on it, we apply force on it, then only it changes its state. That is the Newton's first law of motion. Again, I am repeating, just try to follow this very important thing. Every body continues to be in a state of rest. It is in the rest position only. Or of uniform motion in a straight line, it is in the same motion only. That is with constant velocity. Unless it is compelled by some force to change its state. So the importance of the first law is it will introduce the concept of inertia and also force. The concept of inertia and force. Very important thing. The importance of the first law gives the just the concept of inertia and force. Now, what is the inertia? We had already this just now. What is inertia? Means the ability of the body to change the state of the rest by itself is called inertia. The inability of the body. The body cannot change itself, its state. If it is in the rest, it is in the rest position only. If it is in the motion, it is in the motion only. That inability of the body to change the state of the rest or to change the motion by itself is called inertia. Very importantly, the property of the bodies signifies the inertia. Now, inertia. It is three types: inertia of rest, inertia of direction, and inertia of motion. I will explain the inertia of rest. What is inertia of rest? Just have a look. Have a look now. Here, a person is standing in the bus. If bus starts suddenly, what happens? He jerks backwards. He jerks backwards. Why? That is due to inertia of rest. Just look at this diagram. A person is standing in the bus. Bus starts suddenly. Means what? Actually, the lower portion is contact with the bus. The upper portion of the body is in the air. Whenever the bus starts suddenly, so that the lower portion moves forward, but upper portion wants to keep the rest. So that is why the person in the bus jerks backward. Have you understand? It is inertia of rest. Means the inability of the body to change the state of rest is called inertia of rest. Next, inertia of motion. What is inertia of motion? Have a look. A person is standing in the bus, so bus is in the motion. If driver applies brakes, what happens? He jerks forwards. Why? As you know that the lower portion is contact with the bus, the upper portion is in air. The bus is in the motion means that everything is in the motion. The person is also in the state of motion. When the driver applies the brakes, it stops actually. Means the base is stopped. But the remaining part is still in the motion. So that is why the person in the bus jerks forwards. That is nothing but inertia of motion. That means we can say that the inability of the body to change the motion itself is called inertia of motion. Okay. Next, we'll considering about the inertia of direction. Just have a look. A person is standing in the bus. The bus is taking turn to right side, and you observe that the person who is standing in the bus moves opposite direction. The bus is turning right side, he is bending towards left side. That is also nothing but inertia of direction. Okay, in this way, we will explain about the types of inertia. Okay, inertia is of three types again. They are inertia of rest, inertia of motion, and inertia of direction. How can we explain the inertia of rest? That is the inability of the body to change the state of rest by itself is called as inertia of rest. Just I have shown you the pictures. That is, when a bus or train starts suddenly, the passenger sitting in its bus falls backwards due to inertia of rest. Next, what is inertia of motion? The inability of the body to change the state of motion by itself is called as inertia of motion. I already shown the pictures. A person standing in the bus, the bus stops suddenly, the passenger in the bus jerks forward, that is due to inertia of motion. Similarly, inertia of direction explains that the inability of the body to change the state of direction by itself is called as inertia of direction. I also showed this picture when bus travels towards right, the passenger in the bus falls left hand side. That is inertia of direction. Very important. Hope you understand about the types of inertias. Whatever it may be, the one thing you should remember that the property of the inability of the body to change itself, its state of rest, or state of motion, or state of direction explains the inertia. So depending on the property, we will mention inertia of rest, motion, and direction. Okay. Hope you got this analysis about the inertia. Now, very important physical quantity, force. What is force? Force means it is the physical quantity for which it changes the state of position of the body. Means what? If it is in the rest, or if it is in the state of motion, or size or shape of the body. If you want to change these positions, we'll have to apply the force. It will also mention the push or pull, or which changes or try to change the state of rest, the state of motion, or size or shape of the body. This is about the force. Force is a vector quantity. You know vector. What is vector? This physical quantity which has both magnitude and direction, and those quantities are called vector quantity. Force is a vector quantity. If you want to apply If you want to move the body to any side, you should have to apply the direction so that the force is vector quantity. How can we measure the force? What are the units of force? In Tsrjc system, force measured in terms of dynes. In MKS or other system, force is measured in terms of newtons. There is a relation between the newton and dyne, like meter and centimeter, like gram and kilogram. 10 to the power of 5 dynes is equal to 1 newton. As you know, the newton is a big quantity than the dyne. That is 1 newton is equal to 10 to the power of 5 dynes. So remember, these things will arise while doing the problems. Next one is another important physical quantity is momentum. What is momentum? So momentum is the physical quantity that is the product of mass and velocity of the body. If a body is in the motion means it has momentum. If a body is moving in a straight line, we can represent it as it is nothing but a linear momentum. Body is in the motion means it has both quantities. Those are mass as well as velocity. So that the product of mass and velocity is called momentum. It is represented by the letter capital P. P is equal to, simply you can say, mv. Just I told you that if the body is in the motion means you can say it has linear momentum. If a body is in the circular motion, you can say it has an angular momentum. So whatever the moment may be, the momentum can be represented simply the product of mass and velocity. It is also vector quantity. By means it has both magnitude and direction. If you want to measure the momentum in terms of CGS or MKS, in CS system, mass is measured in terms of grams and velocity is measured in terms of centimeter per second. So that in CS system, you can say its units are gram, centimeter, second inverse, or gram, centimeter per second. In MK system, we can measure in terms of kilograms meter per second or kilogram meter second inverse. Dimension formula also you can write it for mass capital M and for velocity, that is the displacement by time, so that L by T, simply you can write it M L1 T minus 1. In this way, suppose if you know the definition, you can easily write the dimension formula. Without knowing the definition, so it is very difficult to write the dimension formula correctly. So the students, one should learn each and every One should learn about the each and every physical quantity, about their formulas also. Okay, hope you got it. Up to now, we studied about the force and momentum. Now, I'll explain the Newton's second law. I already explained about the first law and the concept of inertia and the types of inertia also. And now I'm going to explain about Newton's second law. What is Newton's second law? The rate of change of momentum of a body is directly proportional to the external force acting on the body to take place in the direction of the force. Or simply you can say the rate of change of momentum is directly proportional to the force acting on it. Very important. The rate of change of momentum. What is the rate of change of momentum? Change of momentum. When the momentum will change. So the momentum will change only if you apply the force on it. So that the change of momentum is depending upon the force you applied. So that is why you can say the rate of change of momentum of a body is directly proportional to the external force acting on the body to take place in the direction of force. This law is used for the measurement of the force. Just see, in the case of first law, it explains the force. First law explains the concept of force. Now the second law used to measure the magnitude of force. Okay. Derivation of force. What is derivation of? What is force? If you want to derive, you have to consider a body of mass m moving with initial velocity u. There is a body which is moving with initial velocity u. As you know, you can represent the initial velocity as u. By applying the force on the body, then the velocity changes. That is u to v. That is final velocity. You already known the terms mass m, initial velocity u, final velocity v, and time t. Very important. Likewise, displacement s. We already learned in our previous classes. While deducing the equations of the motion of the body. Just I want to recapitulate those equations. V is equal to u plus at, s is equal to ut plus half at square, p square minus u square is equal to 2as, and the body displaces in n second, Sn is equal to u plus a and n minus half. These are the equations of the motion of the body when they are moving with uniform acceleration. You already known about those equations. Remember. Okay. A body is moving with initial velocity u. Because of the application of the force, its velocity changes from u to v in time t. What is the momentum? Momentum means mass and velocity. Just I explained you. What is the initial momentum of the body? That is m into u. That is initial momentum of the body is mu. What is the final momentum of the body in time t seconds? That is m into v. That is mass m and final velocity v. That is mv. Initial momentum is mu and final velocity is m. Final momentum is mv. What Newton's second law says? The rate of change of momentum of a body is directly proportional to the force. Rate of change of momentum. Rate means with respect to time. Rate means with respect to time. Now come to the point. Force is directly proportional to the change in momentum by time. What is the change in momentum? I already told you the initial momentum is mu and final momentum is mv. Therefore, the change in momentum is nothing but the mv minus mu. That gives the change in momentum. So that substitute the change in momentum as mv minus mu and the time as t. So that mv minus mu by t. Therefore, F proportional to mv minus mu by t. Understand? This gives what? Change in momentum. Change means difference. That is final from initial final from initial. That is mv minus mu. Okay. F proportional to mv minus mu by t. Take m is common factor. Therefore, v minus u by t. This v minus u by t is equal to a. I already know this equation. This comes from v is equal to u plus at. You know v is equal to u plus at. V minus u is equal to at. Therefore, a is equal to v minus u by t. So, v minus u by t as a. Just substitute the value of a. Therefore, F proportional to ma. If you want to remove the proportional, then just you keep is equal to a constant. That is k. F is equal to kma. In the place of proportional, just you write is equal to a constant. So k is nothing but a proportional constant. Has the value 1. If you take k as 1, that is equal to F is equal to ma. That means the force is equal to mass into acceleration. What is A? Acceleration. You know acceleration. That is the rate of change of velocity is called acceleration. So that force is equal to mass into acceleration. See here, Newton's second law measures the force. What is the formula of force? F is equal to ma. If you know the mass of the body and the acceleration, then you can easily calculate the force acting on it. Very important thing, very important derivation. Hope you understand this derivation. Students, if you know the second law and you can easily derive the F is equal to ma using Newton's second law. So that is why this law is used for the measurement of magnitude of force. Okay, next. Another important physical quantity, impulse. What is impulse? Impulse means it is the product of force and time. The product of force and time of is nothing but impulse. We can represent this impulse as I. I is equal to force into time, that is F into T. It is also a vector quantity. Okay. What are the units in Tsrjc system? Force is measured in terms of dynes and time is in terms of seconds, so that it has units in Tsrjc system as dyne second. Similarly, M.K.S. system, it is measured in terms of Newton second. You know, in M.K. system, force is measured in terms of Newton and time is measured in seconds, so that in M.K. system, its units are Newton second. Similar, what is the dimension formula of impulse? So force into time, force into time. So force into time, if you take this product, finally you can get m L1 t minus 1. In this way, we can explain the impulse. So we can observe this impulse in your daily life situations. Exactly. This, you can observe this impulse. Now, by considering some examples, you can easily understand about the impulse. Take some applications. Very easy. Children, you are playing cricket. You can observe that while you are catching the ball, just you take your hands backwards. Why? Very important thing. While catching the cricket ball, the fielder puts the hand towards backward direction. By the time of action, what happens? So impulse to force decreases. Why? Because force is small and you can take long time to stop it, so that the fielder cannot hurt. That is why for safety, while catching the cricket ball, the fielder pulls his hand backwards. That means to decrease the impulsive force. That means force is small and it takes time, long time to stop the ball. So that is why he feels less hurt. So another example is shock absorbers. Of course, you observe the shock absorbers which are provided to our vehicles, both two-wheelers and four-wheelers. For comfortness, to feel comfort, it is necessary to arrange the shock absorbers for the vehicles. So what happened? Shock absorbers are provided to the vehicles to increase the time of action, and therefore it decreases the impulsive force. Very important thing. The third one, suppose if a person jumps on the sand floor and then the cement floor. In first case, that is in sand floor, he feels less hurt. And in the second case, that is on cement floor, he hurt more. Why? That means a person jumps on the cement floor hurt more than on the sand floor. Why? Because the time of action increases and impulsive force decreases. That means when he fell on the cement floor, he exert more force in less time. That means the impulsive force is very high. That's why he may get injured. Whereas if he jumps on the sand floor, he takes less force with more time to stop. In this case, the impulsive force is decreases. Okay, so that is why the person who jumps on the sand floor cannot get any injuries. The person who jumps on cement floor can get the injuries. He feels more hurt. In both the cases, although the impulsive force is impulse is same, but depending upon the time and depending upon the magnitude of the force, the person suffers like that. Okay, this is about impulse. So very important thing is law of conservation of momentum. Very important thing. It is a set of question for IPE purpose. What is conservation? That is transformation, to change. So momentum, linear momentum, I already told you the linear momentum. What is linear momentum? Linear momentum means the body is moving in a straight line. When it is moving in the straight line, just to say that it has a linear momentum. Now, what is the statement? If no external force acts on the system, the total linear momentum of the system remains constant. Means for two or more bodies in an isolated system acting upon each other, their total momentum remains constant unless an external force is applied. Or simply, you can say, consider the system contains particles. They are moving one another. In their journey, the particles are collide to each other. Here, if the momentum before collision or before attract, uh, the momentum after collision, but the total momentum always remains constant. So in this way, if no external force acts on the system, the total air momentum of the system remains constant. Okay, students. Till now, we studied about very important physical quantities and also Newton's first law, Newton's second law. Here, the law of conservation of linear momentum, very important. So I'll explain this in my next class. Okay, thank you very much. Thank you.
You are completed, sir?